Civil 3D Lab 3, you should have copied over the lab3.dwg file into your own personal file and folder and renamed it. But when you open it up, it should look familiar. This was the file that we used for the first lab, where we were looking down at a subdivision where we had a road, an entry road coming in. It's called First Street, a ring road, which is called Second Street. These purple lines were different subdivision lots, housing lots, and then we had some sort of topography. So in this, if I go over to the prospector menu, you'll see that I have a surface that's already been defined. It's called EG for existing ground. You'll also, under alignments, see that I have center align alignments. Both First Street, which is this one, and Second Street, which is the ring one, have been defined. If I go further into the First Street one, you'll actually see under the profiles that an existing ground surface profile has been created, and that's what we see over here, with this red line being what the existing ground looks like as we follow this alignment. If I zoom in a little bit on First Street, you'll see that the alignment starts here. You also see that convention of 0 plus 0, 0, 0, so I know that this is in metric units, which is why we started in Civil 3D metric. But it starts at station 0, and then over here it ends a little bit after 0 plus 480. And if I go over to here, oh, this text is really small, but it'll start at 0, and you'll see that it kind of has a downslope and a little bit of a incline, and then it kind of climbs steeply. Oh, here it is over here. At station 4 plus 80, it ends at a higher elevation. So this is kind of similar to what we did in the project steps last week. For your own project, you would have defined the north and south alignment, and you would have had two existing ground profiles. So for this lab, we're going to learn how to do our proposed ground. So instead of following the topography exactly, we're going to create smooth vertical curved surfaces and do our proposed alignment, and then take it even further and think about the third dimension, which is the cross-sectional element, and into developing what the earthwork estimates are. Okay, to begin the vertical alignment, you first need to have defined a horizontal alignment and defined the the vertical surface profile. So back under profile, last time we said create surface profile, and if you kind of look at the icon, it's kind of shows sort of jagged, crossing, showing what the existing surface or topography looks like. Profile creation tools, on the other hand, has these smooth tangent lines. So we select that, and the first thing it's going to ask, it says it down at the bottom, select profile view to create profile. So we need to have already created this with the surface profile, so it's just asking for us to select the outer frame. So take, for instance, in your project where you have two alignments, right? You would need to select whether you were defining the alignment for the north or the south. In this case, we only have one, but it still requires us to go ahead and select that. So it's going to default the alignment. This is the horizontal alignment to First Street. It doesn't allow me, you can see that down option, doesn't allow me to change. I can't build my Second Street profile on my First Street surface profile, which makes sense. It'll default to profile type and then what's called counter, so it'll just call it like a generic name, but it can get really confusing about whether you're dealing with the existing ground profile or the proposed ground, so it's good to use good naming conventions. This is particularly true for your projects where you have multiple alignments, vertical alignments. So I'm going to call it propose First Street, and I could put in here a description of it if I want to. So I also have down here the profile style. It's going to default to, it sees that it's a design profile because we selected that, and we're going to keep it at that. This just sort of sets the conventions for how things are look like and what labels they're on and things like that. So this says it's going to draw it in the road profile layer, and it's going to use standard labeling. I could say no labels where I didn't want to know where the vertical points of intersection or things like that. So similar to the horizontal alignment, we want to also move, not just stay on the general tab, but we want to go hit this design criteria. And we're going to use criteria-based design. So it's going to pull the AASHTO. This is the street design standards, or the sort of the most common U.S. standard for roadway design. So it's going to pull the speed limit from that we defined when we did the horizontal alignment, and it's going to use that again and make sure that from a vertical standpoint that the cars can travel at that design speed. Like I said, we just kind of gloss over a lot of the transportation design stuff, and we'll talk about it more in depth the junior year. But I'm going to hit OK, and then it brings up the profile layout tools, which look a lot like the horizontal alignment layout tools. Right? So, and the first option, I can draw with tangents, where it will just draw tangents without any vertical curves, but I want to go ahead and do my full design and draw with tangents with curves. So we're going to draw this within our surface profile. So in most cases, when you think about roadway design, particularly in the U.S., we try to have really smooth surfaces so that our roads don't have a lot of topography changes, so that we try to hold our grades and have smooth transitional curves. And to do that, we wouldn't just we wouldn't build the road exactly to the existing ground. If you think about roads that you drive, some cases they're sort of built in or cut into the hillside. Other places they sort of stand above the surrounding ground and fill. So we're going to do the same thing with our proposed design. But there are two places where we do want to match the existing ground exactly, and that's right when we begin and right when we end. So I'm going to make sure that my O-snaps are on down here at the bottom, and I'm going to go ahead and select that point where the existing ground exactly intersects with this blue line, which is the very beginning of my alignment. So if I zoom back out, now I want to go ahead and turn the O-snaps off, because I just want to start approximating the existing ground. So I'm not going to follow it exactly, but I generally know I need to go down. Right? And as you draw, you'll see this vertical curve get drawn in there. So if I draw it too close, I know I'm going to get an error because it doesn't have enough space to draw in a vertical curve to meet my design speed. So if I put another VPI out here and here, and then I'm going to go ahead and get to the end, turn my O-snaps back on, and exactly select where that red line intersects the ending elevation, and hit enter. Now it's going to go ahead and label this. I'm going to see that I have a downgrade, I have a vertical curve, I have another one, and finally the end. Similar to what I did with the horizontal alignment, I can bring up the grid view, which brings up the details about my alignment in the panorama. So I see that I have an error here, and if I look down at my drawing closer, I can see that I have another error in there as well. So if I look more closely, what it's telling me, so it's showing my vertical point of intersections, my VPIs, or PVIs. Sorry, those are kind of interchangeable, VPI and PVI. It's in the elevation and what my grades are, and then I can see that I might have some issues with my design. So if I look a little bit more closely at what's going on, or I hover over it, it says that I don't have enough passing sight distance. So what it means is that my vertical curves are not long enough that I would be able to allow for passing on my road. So when you think about when you're doing a passing maneuver, you need to be able to see pretty far ahead in order to be able to make a decision about whether it's safe to pass. Well, when I think about the road that I'm designing, it's just an entrance to a subdivision. I wouldn't think that people would be passing on a local road like that. So even though I'm getting a warning, I'm going to go ahead and let that go because it's not a safety issue. Now if I had what's called a stopping sight distance, right? So this is something that is required on every road that we have. And like I said, we'll talk more about it in the junior year, that this would be a violation that would be unacceptable, which is why it went ahead and drew it at this, this minimum, what we call K value. We're not going to talk about K values too much in this class. We really spend more time worried about curve length, vertical curve lengths. Horizontal curves are defined by their radius in general, or degree of curvature. Vertical curves are defined by the length of the curve. And anyway, so if we multiply this K value by what we call the grade change, that's where this value comes. But like I said, this is just giving us a warning that we're designing a road that you would be unable to pass in. And you can see that in order for us to allow for passing, we would have to change this value all the way to 30, which would, it would not fit within there. So anyway, so similar to how we changed the radius in the horizontal curves, this is where we would be making changes to our curve length. Either in this value, or we could change the K value. They're a function of each other. So I'm going to go ahead and close this, and I can close that. If I want to get back to that menu, I would just have to pick my vertical alignment. I would see that it brought up a profile ribbon, and then I would have this geometry editor. So this is similar to what we did with the horizontal alignment. We had to select a horizontal alignment. We had to select the geometry editor. It had a different icon at that point, but it was named the thing, and that would bring up this menu. We're going to look at a couple different options for editing our alignments, but at this point, one of the things that you can do is you can actually just go ahead and pick up your PVIs, and you can move them around, and you'll get different errors will come up. So I moved that one, and I saw that it came up with that error, and I could look at it, and it says headlight sight distance. So this is not the passing sight distance. I might not know exactly what it is, but it means that it would be sort of unsafe for people driving at night. So that's probably not a good thing. So I can bring that up. Right, and you can make changes, because if you visualize what's happening here, this blue line is our proposed and this red line is our existing. So it means to build this road that we're going to have to cut into the hillside, or cut into this mound that we have, by a pretty significant vertical difference. These are in meters, right? And so this is from about 39. If I hover over it, you'll be able to see in this pop-up menu that point right there is about 39 meters. And if I hover over here, I'm going to bring it up, it's 40.8. So I have about almost a little less than 2 meters of cut that I would have to do. And the same thing is, I could look at the difference between how much I'm going to have to fill. I'm going to have to bring in material to build this road up. So I think for now I'm going to go ahead and bring up that geometry editor and just look at my curve lengths. It looks like I made them too short, so I'm going to change this. I can see that it needs to be 13. In these cases 13, and just hover over it and make sure it's just the passing sight that I'm okay with. So we now have a horizontal alignment, we have a surface, we have an existing ground profile, and we have a proposed ground profile. So the next piece of the puzzle is to think about the roadway in what we would consider the third dimension, which is the cross section. If we go back up to the home menu under Create Design, where we've been spending a lot of time with our horizontal or vertical, in Civil 3D we call cross section, we call them assemblies. So if I go to this down arrow, you can see that I have a create assembly. So I can call it, I'm going to call it First Street. In your project, you may assemblies are often not just named for the street. They could be, if we think about a typical two-lane road with bike lanes or parking, we can use that cross-section of road on multiple alignments. So in your case, for your project, you probably are going to use the same assembly for both the north and the south. So in that case, you could just call it street. You don't have to be specific to First Street versus Second Street. But I'm going to go ahead and call this one First Street. Maybe in this project, I would have a different cross-section for First Street as the main entrance road. Maybe it's a little bit wider or has parking, and then Second Street might be narrower or for whatever reason. But I'm going to go ahead and hit OK. And then it's going to ask me where I'm going to create this assembly. So I just need to pick a blank spot in my drawing. And then it creates this, I think of it as a target. But if I'm viewing this as a cross-section of a road, this is actually going to be my center line. And at this point in the center of this red target is going to be sort of the intersection of my vertical and horizontal alignments. So this line right here is going to follow my horizontal alignment, and here this is going to follow my vertical alignment. And so I'm going to be building off like the sections of my road off of this. So anyway, I could zoom out and you'll see that it's to scale. So when we think about how small a road is relative, to a long length, but a relatively narrow width, that's why you see it's small. But it automatically zooms us in and gets us to where we're going to build this piece off of. So the pieces that we're going to build our road from is called a palette, right? So over here on that home menu, we see this palette, and if I hover over it, I see that this, I don't know what it looks like, but if I hover over it, it's called a tool palette, and I click that, it's going to bring up another menu that I can dock or move around. But this tool palette is common things that we're going to build a road from. So there's common assemblies that I could just define, but in this case I'm going to build my roadway up off of basic components, right? And so it says it's metric because I'm, remember, Civil 3D metric, and these are some of the pieces that I can have on my my roadway. I can have travel lanes, which could include where we the lanes where the cars are going, but also could be parking, and I can have shoulders and curb and gutters and guardrail and things like that. So the first thing I'm going to do is select a basic lane. So if I hit that, I guess I'm supposed to think like an artist. This is a palette. I've picked up this color, and if I click it, right, it's going to build in a lane. If I click it again, it's going to build a lane on the other side. So it tends to want to have things be symmetrical. I'm going to go ahead and hit enter to kind of get out of it because I don't want to create any more lanes. And in general, we haven't talked much about this in other labs, but any object, if you double click on it, it'll bring up properties to it. And so it'll bring this property menu. And these, the properties of these Civil 3D objects, these lanes, are pretty important, but most of them, if I look at what's going on down here, it's setting the slope of it. It's saying that it's going to drain 2%, right? I could change this to a positive 2%, and you could see that it rotated it around so that now the entire thing would be draining to one side. I could oversteepen it. In general, our roads are going to be, the most standard roadway design is the center line is the highest and it drains away at 2%. If I wanted to change the width of my road, right, I could change it to 4 meters and it would lengthen that out, and it would hold that center line constant and it would push it out in that direction. I'm going to go ahead and leave it at the 3.6. Right. But if I wanted to, maybe I had 2 lanes, right, and they were each 3.6 meters wide, right? I might double this to 7.2, or if I had parking, or if I had bike lanes. In this case, it's really just talking about the pavement surface. It also is setting a depth for how much of layers I have. In a basic assembly segment, it doesn't talk about what each layer is, but if I go to some of my more advanced types of lanes, I could set, how much asphalt I have over gravel and other components to my pavement layer. But for this class, we don't want to get into it, and we're just going to use basic segments. So I have my lanes. In this case, it's a subdivision, so it's pretty common to have curbs. I could have curbs, which are just straight, or I could have what we call basic curb and gutter that has a concrete gutter pan that's sort of integral or with the curb. So I'm going to put that, select that, and you can see that I get this box. This is a selection box, and it's going to ask me, it's similar to like snapping, but if I go ahead and pick this red circle, it's going to automatically match the top or the insertion point of this curb and gutter with the top of the pavement, so that you can see I have a smooth pavement layer that's exactly matched to the beginning of my concrete gutter pan and my curb. So I can go over here and I can do the same. So now I have a curb and gutter. Okay, so I want to also add sidewalks. So I change and so go ahead and select sidewalks. Once again, kind of zoom, and I want my sidewalk to match here. So it puts the sidewalk there, and it puts the sidewalk there. And I hit enter. Just to bring up that property menu again, I just double clicked on it. If you dock too many things, you don't have any space left. But if I go ahead and look at this, it's setting my sidewalk to 1.8 meters. It's setting the depth of the concrete to 0.1 meters. But it also has some things in here called buffers. So I could set, if I had a planter strip, I could set my buffer at 1 meter, essentially 3 feet, and it would push that so I would have separation between my sidewalk and my curb and gutter. Once again, we don't want to get too into it in this class, but just see how these are sort of smart objects, and they have a lot of the common criteria that we would use when we were making decisions about how our road should be. I'm going to go ahead and shut up that property. So, as I mentioned, it's going to take the center where this blue X is, and it's going to follow my horizontal alignment, and it's going to follow the blue vertical alignment with this. But the piece that I don't have is what's going to happen at the end, right, at the back of the sidewalk. So I'm showing here that my proposed is pretty significant, and I think we measured it a second ago, that here I was almost 1.8 meters, so maybe 5 feet above. So if this road, essentially would be sort of going in and out of the computer at this point, is not going to be at ground level. So what's going to happen at the back of that sidewalk? How do I get back to my existing ground? And so there's one more element over here that I want to add, what's called a basic side slope cut ditch. So I'll put it in and then I'll talk about what it's doing here. So I'm picking up that one, and I want to pick the back of my sidewalk. If I had put a width on that buffer 2, it would have created a flat spot behind my sidewalk before this element, but I want to go ahead and have it at the back of the sidewalk. And so it's allowed, what it does is if this assembly is above the existing ground, at this point it's going to create a slope, a fill slope, an embankment slope, as long as it needs to until it intersects with the existing ground, right? So it's a smart element in that the distance between this intersection point and the back of the sidewalk is going to be whatever it needs to be to match, right? And the same thing is if this happens to be the proposed happens to be below, or the blue line happens to be below the red line in the profile, it's going to come up and it's going to create that cut slope, and it's going to go find and intersect with the existing ground, however long it needs to be. And if I look at my properties, I can see that it's going to do a cut slope. It's going to cut at 2 to 1, and that means 2 feet horizontal, or 2 meters horizontal, for every 1 meter vertical. And it's going to fill at 4 to 1, so 4 meters horizontal for every 1 vertical. And we'll talk more about this in class. It also will create some ditches, right, and all the necessary features. There's a lot of elements that go into this cut and fill slope. But without these elements, this cross section essentially would float in the air or be underground, and it would have no ability to sort of connect dynamically with what's happening with the existing ground surface. Okay, I'm going to go ahead and close this. And close the cancel. That's not what I want to do. Save it, and I just wanted to show that, there it is. I can close the palette since I'm not going to make any more assemblies. There it goes. And just point out that you can see the assemblies are stored in Prospector for Street, and you can see the pieces, right? So the basic lane, right, each of these have properties that I can also change the parameters in here, as opposed to double clicking and going to the properties menu. So anyway, so the next piece is to tie all these things together. So if we have information about our horizontal alignment, our vertical alignment, and our cross section, the piece that's going to bring them all together is called a corridor. So up at the Home menu, under the Create Design panel, we see this corridor piece. So if we select this, it's going to ask us to create the corridor. It's going to default to the name of the alignment that we have. So in this case it's pretty clear because we only have one alignment, vertical alignment, so First Street, but in your case for your project you would have multiple. So we could describe it. It's going to default to sort of basic styles. This is how it looks on the screen, and the pieces it's going to show, what layer it's going to put it on. And then it's going to say, okay, what is our horizontal alignment? So we have multiple ones, but we're going to follow our First Street, right? Our corridor is called First Street, so our horizontal alignment needs to be First Street. And probably the most common mistake that's made in corridors is figuring out what it's going to follow. And for some reason, this is frustrating with me with Civil 3D, because I think that it should default to proposed alignment, but in this case it shows both. It says I could follow the red line. So when I talked about that bullseye, or that target in the assembly, is it going to follow the red line, which is the existing ground surface, or is it going to follow the blue line, which is the proposed First Street? So obviously it needs to follow this one, and not selecting that just means that it's going to follow the red. So it's going to make your earthwork look pretty good, but it's going to make your vertical alignment be something that really is undrivable. So this is our horizontal, our vertical, so make sure we make that change. And then the last piece is the assembly, or sorry, the second to the last piece. So this is just what we can have multiple assemblies, so what cross section is going to be done. And then here, probably the other common mistake. So corridor definition is where 90% of the questions about your project will come from. So just take a little bit of time and kind of go slowly through this when you work on your project, because it's easy to make a mistake. Now fortunately it's easy to fix it, or easier, I mean it's possible to fix it without redefining things, but just making sure you think through each of these steps. And then the last piece is the target surface. So when I talked about that cut and that fill from the back of the sidewalk and how it was going to find where the end of that embankment or that cut slope is, this is the piece you need to tell it that it needs to go find the existing ground, right? So we're going to say OK, and put it over here, and it's going to show me in essentially the same information in a slightly different view. Why this view is important is if you make a mistake and you need to go and make changes to it, this is where you would fix it under the corridor in the prospector menu. But I'm going to go ahead and hit OK. Corridor definition needs to be rebuilt. Anytime you go back and make a change, if you decide you want to have 4 lanes instead of 2 lanes and you change your assembly, or you make changes to your vertical alignment or your horizontal alignment, this rebuild the corridor. If the corridor is no longer valid, you can mark it as out of date, so it won't. It'll still be in your database, but it won't be updated. But in most cases, you're just going to do rebuild corridor, and it's going to bring in all of this information. So I want to just point out in the prospector menu that I now have First Street under my corridors, and if I do properties, this is where I can start to make changes. Like if for some reason I picked the wrong vertical alignment, if I forgot to change it to proposed and I just used existing ground, this is where I could make a change. I'm going to go ahead and make a change just so you can see something that happens. And if I hit apply, right, it always wants me to rebuild, right? So I'm going to just show that rebuilding process is the step where it makes changes. So if I were to go back over to here and make a change to my vertical alignment, right, you'll see over my prospector menu I got a warning. Essentially, I need to rebuild because I made a change, and that corridor step is where it builds it all together. So having your prospector menu open to your corridor so you can see those exclamation points is really important so that you can make sure that your corridor is really using the most current pieces as it builds it all together. Okay, so I'm going to look a little bit more closely at these lines that it put together. So if you remember back to our assembly, it said we defined we were going to have a lane on each side. So what this did is it drew some line work, and it said that here's my center line, here's the front of my curb, right? And then I have some additional curb work, right? The bottom and the top of the curb, right? And if I hover over them, I can see this is the flow line of the gutter. This is the, I guess, the edge of my basic, right? And then I start to see my back of curb. This is a hinge point, which is also known as the back of my sidewalk. And then I can start to see how it's doing cutting and filling. And so the ends, these lines that are coming out here, this is where it's matching with the existing ground. It's finding that it's intersecting with the topography of the road. I think it's a little bit easier to view this in another view. So I'm going to go ahead and select this corridor. Right, this brings up a corridor menu, and you can see this section editor. So if I push the section editor, yours hopefully defaults to a little bit better view. Okay, so if yours looks like mine, what we're looking at is the cross section. It has a lot of labels on it, but what we want, I'm going to go over to viewport configuration, and I want to do 3 above, see if it can change to the correct. Yeah, this is what I'm used to seeing. So it's bringing together what's happening in the horizontal, what's happening in the vertical, and the cross section. And you can see this white line right here at station 0 plus 0, 0, 0. There's another white line right here, and then I'm seeing it here. And what it's doing is it's showing me all 3 views at the same time. And I can zoom into each one of these. But if I look carefully at what's going on here, you'll see this target, and you'll start to see the basic lane, the curb and gutter, the sidewalk, And then in this case, at station 0 plus 0, 0, I know that that's what station I'm at because I can also see it up here. That I'm slightly, I'm matched right here at, because remember by definition we said that we were going to put the, begin the vertical profile right at existing ground. So, but this red line is showing the existing ground, and anyway, it's sloping. The ground is sort of sloping away, so by the time I get to the back of the sidewalk, the back of the sidewalk is up in the air, so I have a fill slope. And remember, it's going to go at 4 to 1 until it matches. And the same thing here, if I kind of highlight on that red, that existing ground, there's a little bit of fill. That back of sidewalk is going to be a little bit higher than the ground. And so up in here, oops, sorry, I zoomed to the wrong place. If I make each one active, right? The back of these outer green lines is where those are matching, right? So that's how far out from the back of the sidewalk it needs to go until it can match, right? So these become important if we want to know how much impact our road is having, right? How much, so you can see in some places it gets pretty far out. So if I were to hit this kind of play, it'll go in even sort of 25 meter stations. You can see in this case the sidewalk is here, the existing ground is way up there. I have to cut away, and anytime it's in a cut, it's actually going to create a little bit of a drainage ditch so that it collects the water down here and the water doesn't just run onto the sidewalk. That's one of the elements that is part of the standard cut and fill slope. We're not going to get too into the transportation or the hydrology or hydraulics of that, but we'll just go ahead with it that anytime it's in a cut section, it's going to put a ditch over there. So, which starts to explain what some of these other lines are that we see. That when we're out here, that it has some ditch sections in there. You can see this is the ditch on both sides, because in both cases it's in cut. So I can keep moving along and going through. As soon as I exit out, it should take me back to the common view. In some cases, it gets a little confused and it stays in the 3-section view, but we can always go back to here under the view menu and change it back to single. Part of the lab, we want to move into starting the steps to determine the changes or the estimated earthwork volumes. So looking back at the profile, we saw from the blue line that there were many places where there was a significant difference between the proposed, or the blue, and the existing ground, the red, which indicate that there's going to be cut and fill volumes or earthwork volumes that are necessary to build the road as designed. So we'll want to be able to determine the estimated cubic yards of cut and fill for our project, which is called calculating the earthwork. In order to do that, we need to take our corridor a couple of steps further. So we have a 3-dimensional surface for our existing ground, and we have lots of 3-dimensional information about our corridor, but right now they're 3-dimensional lines. So we have information about what the center line is doing, and then from that we built off, what the estimated, sort of elevations are for the gutter and the top of curb and back of curb. But we need to take that so it's actually a 3-dimensional surface and not just sort of separate 3-dimensional lines. And how we do that is we go back over to the prospector menu under corridors, right-click, and bring up the properties menu. And we saw this before. I had pointed out that under parameters, this is where we can make changes if we defined our corridor using the wrong surface or the wrong alignments. This is where we can make those changes. But there are 2 other tabs back here that we want to work on to be able to create a corridor surface. So under surfaces, over here on the left, we're going to create a corridor surface. So this sort of defines the space where information is going to be held. And then now we need to tell it which of these three-dimensional lines we want to build the surface off of. Well, actually, there's three-dimensional lines and sort of three-dimensional links. So from the links, we want to specify different codes. We're going to specify the top. So the top of our surface is going to be the top of our road as defined from our assembly, and we're also going to add the daylight. Now if the daylight doesn't show up, this is a fairly common issue that students run into. It's because you forgot to put the cut and fill element from the tool palette into your assembly, and without that those elements behind the sidewalk, it has no ability to sort of go and find the existing ground surface, so you wouldn't have daylight available. So if for some reason you don't have daylight, then you have to go back, find your assembly, and go ahead and add that cut and fill, rebuild your corridor, and then come back to this step and you'll see daylight show up. So for under links, we're going to add daylight and top, and under feature lines, we're going to add the back of the curb and the top of the curb. The next step is to add the boundaries, and this just limits the three-dimensional surface to certain boundaries, and it prevents, and well, first we're going to add it and then I'll talk about what it's doing. So add automatically our daylight line. And so what this does is it sets these outer daylight lines as the boundary of our surface, and so you're not allowed, or the surface doesn't interpolate outside those boundaries. So it wouldn't create an interpolation or a tin line that sort of went from a point over here to a point over there. This is particularly important when you have a lot of curvature where it might want to sort of stretch across, and so it limits all the interpolation to inside these boundaries. So I'm going to hit apply. It's going to ask me to rebuild the corridor because I've made, anytime you make a change, it's going to want that. I'm going to close it. And now if I go over to my surfaces, you'll see that I have a new corridor surface. So the pentagon means it's a surface, but the pentagon with the road just means it's a corridor surface. So I have now an existing ground, and now I have a proposed ground that represents what's happening with the First Street. Okay, at this point we want to do some visualization of what we've designed. So I'm going to go ahead and select the corridor. You can see how it's highlighted, and that brings up the corridor ribbon. We're over here with the section editor a few steps back, but there's also a feature to the right of this called Drive. So if I select that, it's going to ask me which feature line I want to drive. Now I can try to select it, or I can just hit try to go in there. It's sometimes it wants to, so there, that was grabbing the alignment. I need to make sure I grab the actual corridor line, and I'm just going to select crown. It's going to take a second. It's kind of a big command. Okay, so and there's a lot sort of happening here. Anyway, it makes some changes to my view. I'm kind of, but up here there's a play feature, and then we'll kind of come back and look at some of the other ones. But I'm going to go ahead and hit play, and what it's going to do is it's going to drive my corridor. Now, anytime that I'm in cut, you're going to see the existing ground sort of cover the road, so it looks like I'm going through kind of a snowbank. But depending on how fast your processor is, my computer's kind of bogged down. I'm kind of low on space, but it'll start driving the roadway. So you can see what's going on with the various elements with the curbs. You can see the cut and fill and all that. Yours, I imagine, will kind of run a lot faster, just because you won't be quite so bogged down with lack of drive space. But up at the top, you can change how fast you're going. You can also change elements about your how high your eye height, We'll talk about this more. Actually, this is your eye height over here, 3.5. So your road might look different if you were in a freight truck versus a sports car. So we'll talk about this more in junior class about why eye height is pretty important for roadway design. But anyway, it'll be a little bit more interesting for your projects because you'll have a longer road, and you'll be able to visualize sort of the cut and the fill areas and see what's happening. So that's kind of a nice feature. But the drive feature really helps you with seeing how the effects of your horizontal alignment, your vertical alignment, your cross section, and your existing ground, how all those things play together. Okay, I'm going to go ahead and close out of this. Sometimes just because it's a big command, when you close out of it, you might be left with some residual. Sometimes it leaves with some solid surfaces. Anyway, the way it looks might be kind of wonky. One of the things that you can check if that's the case is you can go over to the view menu and make sure that it's saying 2D wireframe. Sometimes it's left in this conceptual where it takes and puts solid surfaces on the tin lines. And anyway, you can go and change that. Other times it might leave you in a strange viewport where you have multiple viewports, but you can go back and change to your single viewport here. The first step in moving towards figuring out what our earthwork volumes are, now that we have the corridor surface, is to create sample lines. If we go back up to the home menu, we've been working over in this create design panel, but just to the right of it you'll see sample lines. And what sample lines are, I'll kind of bring this up where you can read the description from Civil 3D, but sample lines are the locations where we're going to compare the area. We're going to compare to see how much cut and fill there are, and then we're going to average those over the length, and this is called the average end area method. And I'll explain a little bit more once we see what the sample lines look like. But first I'm going to hit this, and it's going to bring up the sample line menu. It's first asking us, you can see when I hover, to select an alignment. So I'm going to want to select First Street, but because I have this corridor over the alignment, it's actually a little bit difficult to select. So if I just hit Enter, it'll bring up all my defined alignments. You'll see First Street and Second Street, and so I'm going to pick First Street. But that's often an easier way to do it than trying to be able to pick it when you have all these corridor lines over the top of it. So it's going to want a name. It's going to default to something, but I think good naming convention. So I'm going to say these are the sample lines for First Street. You could have you could sample the first part of it differently than the second part. Not often done, but sometimes you might have different material. Maybe you have high quality material at the beginning of your alignment and low quality material at the end, and you might want to sample those differently so you could know what your different material volumes would be. But I'm going to go ahead and leave all the defaults. I'm just going to change the name of it and then hit okay, and once I hit that, you can see, it's a little hard to see there, I'll do it this way. You can see where I have this red line kind of following my cursor. The circle part of it is going along the alignment, and then wherever I pick, it's sort of perpendicular to that. And so I could manually go through and select where I want to create these sample lines. But instead of manually doing it, I want to do it sort of systematically. When I said enter that command, it brought up a sample line toolbar. It threw mine on the other screen, so you might have to look around for it a little bit. But over here is an option of ways we can create sample lines. Right now with the check mark, it's defaulting to add a station, which is where I can either enter or click and it would manually create that. I want to use this option, which is called by range of stations. So instead of doing it one at a time, it'll do it over the entire alignment based on some parameters. So if I look at these, it's asking me if I'm going to start my station range at the beginning of the alignment, so it's saying true. So it's going to start at the first station and go to the end. I could say false and then overwrite this if I only wanted to do a portion of the alignment. The next 2 are asking how wide these will be, and so these are distances off of the center line to the left and the right, and we'll talk about why these numbers are important. This is a value that will be important for your project. But right now it's setting it at 50 meters to the left and 50 meters to the right, so a total width of 100 meters, so over 300 feet, which is pretty wide, and you'll see that once we create them. I'll talk about it a little bit more. Then it says sampling increments, and this is where it's going to automatically do. So it's going to set a sample line every 50 meters. This is almost over 150 feet, which is pretty far. If I were doing this for real, I would probably change this maybe to 25 meters or 20 meters. When you go to do your project, you're going to be in English units, and it's going to do swath widths of 50 feet to the left and right, and those are probably going to be a little bit small. But it's also going to sample at 50 feet, and that's a pretty typical value. We'll talk about some of the logic behind how we make decisions about these values once you kind of see what's going on. And then down here, I want to make sure that I have a sample line at the very beginning and at the very end, and yours might default to false, but you want to change at horizontal geometry points. So it's going to force it to have a sample line at all the points of PCs and PTs. So I'm going to hit OK. And it brought up all these blue lines. It also then kind of put me back into that manual mode, so I can sort of supplement if I feel like I don't have enough stations. But I'm going to go ahead and hit escape and get out of that. And so it at that point it kind of finalized the sample lines, and it put some station labels. So you can see that I have sample lines at the beginning and then every 50 meters, and so for your project you're going to have it every 50 feet. Now when I talked about the swath width, I said that we saw it was 50 meters to the left and 50 meters to the right, and so that's pretty large, and so we get the full 100 meters. What we're looking for here is we need to make sure that these sample lines are longer than our daylight lines. So on your project it defaults to 50 feet left and right, and you can get into situations where it's not quite long enough. So I would suggest that you probably want to change those maybe to 75 feet on your project. But really what you're looking for is you want to make sure that you're capturing the daylight lines. So we'll talk a little bit more about that, but essentially you would have this is the point, remember, where your cut and your fill lines intersect with your existing ground, and if we're trying to calculate earthwork volumes, we need to at least look beyond that point, or else we're going to be missing significant amounts of earthwork. Okay, to visualize what the sample lines are doing, let's kind of go back to the section editor. So I'm just going to go ahead and select my corridor, and then bring up this section editor that we did in an earlier step. And I know I have a sample line at station 100, so I'm going to go ahead and do that. And so if I look at what's going on, kind of looking at the section side of it, what's happening, I can see at station 100 my existing ground is down here, and it's pretty flat. And then my roadway alignment is higher than my existing ground, and I could see that here, that my blue line, which is my existing or my proposed ground, is much higher than my red line, which is my existing ground. So that means that I have fill, right, and then I have these embankment slopes, and so these daylight lines are out here on the left and out here on the right. And so at every sample line, it's going through and it's calculating an area. It's saying how much of my section is in cut or in fill. And so at station at 100 meters, or 0 plus 100, I am completely in fill. I have no cut material. I'm building the road up above that surface. So we'll kind of, and so it's going to look and figure out these areas of cut and areas of fill at each one of these blue sample lines. Now it could be, if I had existing ground topography that was sloped maybe from left to right, I could have a section where half of it was in cut and half of it was in fill. So I'm not required to be sort of one or the other. But just kind of keep that in mind when we start looking at the results that we get. Okay, I'm going to go ahead and close out of my section editor. And now I want to start computing the materials. And to do that, I need to actually select a sample line. So any one of these blue sample lines will do, and you'll see that it brings up another one of these context-sensitive ribbons, so it says sample lines. I can make changes or edit my sample lines. This is where I could go through and change the width. Maybe it was wide enough, but I had one area where my daylight lines did extend. I could go in here and change those. But what we want to work with is over here in this Launchpad view. So I'm going to go ahead and select Compute Materials. So it's going to ask me what am I doing. So I have the only one alignment have I taken far enough that it would be able to see that it's an alignment that has a sample line group. Now remember, I could have multiple sample line groups for a single alignment. Maybe I separated my sample lines between the beginning and the end. Maybe the project was going to be done in phases or for whatever reason. But in this case, I only have one alignment that has sample lines, and I only have one sample line group for that. But I want to go ahead and hit OK, and it's going to bring up my computing materials thing. And you'll only see this the first time, and we'll kind of look and see what happens when you kind of go back and make changes. But the very first time that you set up your materials list, you'll see this, and it says, okay, tell me what I have for my different existing ground, right? So I have I want to set that as my existing ground. If I do it there, it sets it for everything, and I'm going to use as my datum. I'm going to set First Street. For that, I'll hit OK. And then when I go back and look at Compute Materials again, now that I have it, you'll see it in a slightly different view. So it says that the ground removed, it's going to call that cut, and ground the embankment material, it's going to call it fill. So when we do a project, right, we're generating material when we're cutting it, right? So you can think about areas where we have to bring the existing ground down and cut it away. We would move it over to a stockpile. And then there's other areas like the one we just saw in the section view where we're filling the material. And right now these factors are done at 1. But we're going to talk more about it in class, but I just want to make sure this is clear. When we take, if we build or we cut out a cubic yard of material, so think of a yard, so 3 feet by 3 feet by 3 feet of material, and we go and we put it in a stockpile, and then somewhere on the project at a different station we know we need to use that material. Well, when we cut it out of the ground, it's going to be compacted in what we call in its in situ state. And so depending on the type of sort of geology of the site, it might be compacted to various layers. But in most cases, when we take a cubic yard of material and we go put it in a stockpile, and then later, or maybe we put it directly into the truck, but we know we have to move it to another area, and the wind is going to blow. In that truck, it's going to be in its uncompacted state. And then when we move it, and maybe over here we have a cubic yard hole we need to fill, right? So would it be the same amount of material that we would need? Well, you'll talk about it more in soils class, and we'll talk about it in this class a little bit. We typically need to put a factor on it. We know that we're going to compact it. It's going to be an engineered fill. It's often going to be compacted to a greater state because this is material that's going to be underneath the road than it was in its natural state. Plus, we lose material when we put it in the trucks and drive it around, or we put it in a stockpile and we go to do that. So we know we don't have a one-to-one, that that if we take a cubic yard of material out of the ground, that we're going to need 20% more material for the fill. Some agencies might adjust the cut. Some it's a little more common to adjust the fill, mostly because of the way we do our pay factors. We pay the contractor to do compaction on fill, and so we tend to put the larger amount there. So we want to make sure, and we're going to set that to 1.2, which just means a 20% adjustment factor. So down here it's showing that I'm using the average end area method. There's also a prismodal method, but the average end area is the most common. I'll go ahead when I select that. And so what that means is that it's going to take the area of cut at each one of these sample lines that I defined, and it's going to average it. So it's going to say what the area looks like here, what the area looks like there, and it's going to average it and then multiply it over its length. And we'll do some example calculations in class, but just recognize that that's exactly what this program is doing. So I'm going to hit OK. And now up at the top I'm going to generate the volume report. So once again, it just wants to define that the first street and that I have a materials list. And I'm going to hit OK. It'll always bring up this allow scripts to run. Just hit yes, and it will bring the volume report. So it brings up the volume report. It typically puts it in a web browser. Mine defaults to Internet Explorer. I can't remember what the lab computers do. But this volume report, if I go and look at my sample lines that I defined, you'll see that it creates a row for every sample line. And then at each sample line, it's looking at that section view like we did, and it's saying what area is in cut and what area is in fill. Right? And so we had brought up the section editor for 100, and we saw that that area was all in fill and it had no cut. So we're seeing that this is recognizing the same thing that we saw, that it has no area in cut and only an area in fill. And so it's using that average end area method. So it's looking between sample lines and calculating areas. So at the very beginning, it has no volume, right? It has no cut volume and no fill volume because it hasn't averaged it. But when I look between these, it's taking the area and then multiplying it by the length, which is just the difference in the stations. And it's getting how much cut volume we have up until that station, right? And so between these two, we can look at the difference between cut and the difference in fill. We haven't defined any sort of unsuitable material. Sometimes you want to remove maybe the first 12 inches of soil, and because that's sort of the organic topsoil, and you wouldn't use that in an engineered fill situation. So sometimes if you define what your layers are, you might have a smaller reusable volume than you do have cut volume. But in this case, we're doing kind of the simplest calculation where we assume that anything that we cut is something that can be used in the project. And so then we have cut and fill, and then cumulative cut, right, and cumulative fill. So this is saying, you know, up until this point, we have 871, right, because we started the station at the project at 0. Now we've moved to 50 meters. But you can see as we move to the next one, which is at plus 96, it's taken the 871 that we had up until that point and added another 800. So the net volume, so there's usually just the couple of columns that we're most concerned about, and the most important column is this one on the end, and it's cumulative net volume. So it's looking over the project starting at 0 and moving till the end, and it's saying how much sort of net cut or net fill that we have. So this 781 says, okay, I had 871 of cut, but I also had 90 cubic meters of fill. So this cumulative just subtracts this 90. So it's assuming that we're using the fill material as we move along. And so this cumulative just takes care of that. So if I look at it over distance, I see that I'm generating a lot of excess material at the beginning of the project. right? Kind of comes up, peaks up the highest value at 962 cubic meters, and then I start using more material. And in that case, you're seeing over here that I have higher fill numbers than I have cut numbers. And then eventually I reach negative. So at this point at station plus 250, I have negative amounts of material. So in order to create these fills that I have in my design, I need to import material. And actually I see by the end of the project I have almost 6,000 cubic meters of material, which is really quite high. I would have to, when you have a negative at this, it means I have to find material. So I would have to find a borrow pit. I would have to truck it into my site. In general, you want this value to be as close to zero as possible, meaning that you are generating enough material. I don't have to find a place to waste material. If this value was positive, it would mean that I had excess material that I would have to find a place to stockpile it, or work with a farmer or something who needed more soil. So if this value is as close to zero, it's going to lead to sort of the lowest cost and the least amount of sort of trucking of material. I mentioned that it generates this volume report in a web browser, which isn't a particularly useful way to have it. So I'm going to go ahead and just hit Control A and then Control C, and then bring it over into Excel with a Control V, so that I have the volume report in a format that I can save and I can do some calculations with. So for your project, you're going to be required to do some adjustments to get this number so that it's within a target range. So you're going to end up having, for both your north alignment and your south alignment, you're going to have an initial and a final. So just to do that, I'm going to call this first street 1. Right. So this saves what my original earthwork volume is. I'm going to get rid of that so that it looks a little bit better. And then we're going to go back and make some adjustments to our alignment to see if we can improve the amount of material that we're generating and wasting and needing. So. Engineers, one of the fun things about roadway design is there's an infinite number of solutions, but we're often tasked, or typically we're tasked with trying to create a low-cost project, right? So most of these are publicly funded, and so we want to make sure that we're being good stewards of sort of public money. So in order to keep costs controlled, we usually have two objectives with our earthwork. We want to minimize the total number of cubic yards or cubic meters of earthwork. And so that would be, I'm going to go ahead in my spreadsheet and talk about two sums. So if I were to sum that, so my total cut, and I were to sum my total fill volumes, right, I would want the sum of these two values to be as low as possible. And I also would want, I'm going to go put that in bold, and I would want this number to be as close to zero as possible. And so that's going to mean the least amount of work for the contractor, right? So even if this number is close to zero, if these two numbers are large, it's going to affect the cost of the project. And if this number is not close to zero, either in the negative or the positive, it means that the contractor and the project manager is going to have to either find material to borrow or find a location to waste material. So in this case, I see that I have kind of generating a lot of cut right here between station 0 plus 50 and essentially 0 plus 100. So I'm generating a lot of cut. And then I'm generating a lot of fill down here. Kind of throughout, but really starting kind of at plus 275 and going to about plus 450. So that area I have too much fill. So if I go back to my design, I can see, got my stations are up at the top, right? So from 0 plus 50, right in here, right, I can see that large amounts of cut, right? And then over here, I'm generating a lot of fill material. I essentially never kind of catch up to it. So we want to go back and do change our design. And there's really kind of three primary ways that we can do that. The easiest way is we could just go and select this, and I can try to just move my PVIs. So if I bring these down, now remember, I'm going to be worried about two primary changes, right? I want to make sure that these arrows or these error messages are not either headlight sight distance or stopping sight distance. So I can see that once I change that, I'm going to have to make some changes to my curve. But I'm going to go and I'm going to just bring this one down, and I can move it over to the right. I'm going to bring up my geometry editor and the grid view to get to my panorama, so I can start making changes to my curve lengths. I can also pick these up and move my PVCs and PVTs, but I think it's easier to do it in here because I have the criteria right with me. So it's telling me I need to have at least 13 for this, and I have to have at least 7 for this, so that it's okay. Remember, I can have passing sight distance because I'm not going to want passing on this type of road anyway. And I'm going to have that. And so that lengthens my curves. I could lengthen them a little bit more, but eventually these two vertical curves are going to be sort of on top of each other. So when I do that, I want to go over, and I mentioned this in an earlier part of the video, but have my corridor open in this first street. Anytime I make changes to this, I'm going to get this the exclamation point that essentially says I need to rebuild. And so when I make those changes, I'm going to hover over that make sure that that's just a passing sight distance 1. After I've rebuilt the corridor, I'm going to close all this. If I go back and select my sample and generate volume report, you'll see that it's updated, and that now I'm closer. So I'm going to go ahead and hit Control Alt and C and bring up this value so I can compare, so I can have both of these. So I see I've reduced, I now, instead of having to borrow 5,700 cubic meters, I only have to, it's still a pretty large number, 2,500 cubic meters. But you can see how changes are impacted. And then I can also go ahead and add these two numbers. And so I kind of have two objectives where I want to get this as small as possible. I want to minimize these two values. Oops. And get this one close to 0. So some additional changes that I could make. So maybe just by moving my PVIs, let's close, wasn't enough. Maybe I actually need to start making changes to adding additional PVIs. This will be even more important in your project design. But if I go and select that, oh, I have multiple things selected, sorry, bring that in my geometry editor, I might also want to add a PVI. So there's a bunch of different, so before we were using this where we were drawing with it, we can remove PVIs. If I wanted to get rid of one of these, I would select this and then select the PVI and it would delete it. I'm going to go ahead and insert an additional one. So it's just saying show me where. I may or may not want to have my O-snaps on for this, but maybe I want to add an additional one right here. Right? And so it'll put one in there. This is, I'm going to hit escape to get out of that command. But you can see now I have a little bit more sort of degrees of freedom. Right? Now it's just adding a PVI without the curve. If I want to add the curve as well, I want to add this free vertical curve parabola. So remember we talked about in class that it's a parabolic curve. So it wants to know the beginning and the end, and then the curve length. I'm just going to put 500 in there so that I can go through that. Why didn't I add one? I think it's going to have trouble. I'm going to have trouble fitting one in here just because I don't have that much space, but let me try this again. And the next entity, I'm going to put a K, let's say K value. And see if I can fit one in there. I'll put a K value of 13. And there. So now I have an additional curve in there. So I can try to make these adjustments and try to get these blue lines and these red lines as close as possible, but within the constraints of my geometric design. I can't. It still has to be a roadway that meets the desired design speed. In some cases, there's too much topography, and you might have to reconsider your design speed, and maybe it's too curvy of a road, too much vertical, that you might want to lower the speed so that you can get away with smaller curves and just post it at a lower speed. Okay, so for your assignment, you're going to be doing something similar. You're going to be generating the earthwork for both of your alignments, and we're going to start putting some cost to them, which I'll talk about in a little bit. But just a little bit to kind of wrap up the changing of the earthwork. The kind of primary things: you make changes to the blue line, your vertical alignment. You make sure you're always rebuilding your corridor, and then you're running your earthwork. For your project, you just only need to keep in your spreadsheet your very initial earthwork and your final. So you might run through 2 or 3 different iterations, but you don't need to keep them until you've sort of finalized and you've kind of met your target for your earthwork. So just keep those. Those are going to also go into your project report, so make sure you save them on a spreadsheet that you have saved back to the Z drive. If you find that you change the blue line and you're not seeing changes in your earthwork, the most common one is that you have used your red, your existing ground, and you've tied all of your alignment to the red instead of the blue. And just remember that you would want to go back to the properties and look at your parameters, and your vertical alignment needs to be your proposed, your blue line. It's a pretty common mistake to have it tied back to your red line, which is the existing ground surface, and so no matter how much you change the blue line, it's not going to affect your earthwork because your assembly is actually tied to the wrong alignment. So by making those changes, rebuilding, and then running your earthwork kind of over and over, you'll kind of get used to making changes to your vertical alignment.